Alright nerds, so today we're going to talk about how energy is conducted through various media. So we're looking at one particular type of transmission of energy, and that is conduction. So basically you want to understand how your learning goal here is to understand how energy moves through a solid medium, but also liquid and air as well. Most common examples are solids, but when we talk about sand, that won't be the case. Sound, that won't be the case. You also want your success criteria. By the end of this, you should be able to explain how energy moves from one point to another through conduction, referencing the particle model of matter. So you might need to review that, but I think we'll be fine today. So what is conduction of energy? Over here, we see the conduction of heat. We see at one end, I'll kick back into a minute. We see at one end the blue particles don't have much energy, so they're not moving. But these guys are more and more energetic, and as they gain more and more energy, they bump into the particle next to them, which then gains some kinetic energy, which then gains some kinetic energy, which then bumps to the next one, bumps to the next one. And that's how heat, sound, electricity, well, no, that's different. But heat and sound in particular move from one particle to the next. That's called conduction. So it's transferring of energy through direct contact. So they must be touching. So when we talk about electrical conductivity, we're talking about things touching, like as opposed to conduction and induction. It's kind of the same with energy transfer via heat or sound. We're talking about energy particles touching each other, and that direct contact is how the energy is transferred. And energy is conducted through a medium. So as one particle gains kinetic energy, it then collides with the particle next to it, which then gains that kinetic energy because of the impact, then collides with the particle next to it, and so on and so on. The more tightly packed they are, the easier it is for energy to travel from one end to the other. So the more efficiently it's transferred. And heat is transferred through conduction, as is sound. So when we talk about how tightly packed they are, let's have a look to see what that actually means. For example, air, it travels at about 344 meters per second. So there's always that old story of, we're only worried about these, we don't care about the feet. There's always that thing of, like, you know, you hear a thunderclap, or you see lightning, and then you count how many seconds until a thing, and it's that many kilometers away. In actual fact, if it's a thunderstorm and you see the lightning, for every second, it's roughly 344 meters away. Was that lightning strike? And you can see that the denser we get, the faster it travels through, the more efficiently sound travels through that medium. And we can see this, that you can start holding something in a fire and it doesn't get hot straight away, but eventually the heat flows up the rod, or from one end to the other, not because it's going up, but from one end to the other, it spreads out, and it will then burn your hand by conduction. Alright, I hope that made a lot of sense. If there are any questions after that, put them in the comments below, and we'll get back to them as soon as we can. Thanks for watching. Bye now.